Good morning, student. Welcome to TYBSc Organic Chemistry class. I am Dr. Kailas Labhade, Associate Professor, Department of Chemistry, S.V.K.T College, Devdali Camp, Nashik. Dear student, during last few lectures, we have started rearrangement reaction and we have seen various rearrangement reaction. Now in today's lecture, we are going to see some important multiple choice question related to rearrangement reaction. Session agenda of today's lecture, we are going to brief some important rearrangement reaction, and after that we are going to see multiple choice question based on the rearrangement reactions. Learning objective of this session: at the end of this lecture, students should able to understand or students should able to become familiar with the starting material, products and reagent involved in various type of rearrangement reaction. Students should able to select correct alternative based on their knowledge of rearrangement reactions. Before starting multiple choice question, we should see some important rearrangement reaction in brief. First is Beckman Rearrangement. As you already know that Beckman Rearrangement is the rearrangement of catoxyme. These catoxymes are obtained from ketone. Ketone, when treated with hydroxylamine, there is formation of oxyme, and when this oxyme is treated with acid, there is formation of N-substituted amide. This is the Beckman Rearrangement. Important thing in Beckman Rearrangement is that migration of group with respect to anti with respect to OH is taking place. Another rearrangement, that is Beer-Villiger rearrangement reaction. It is also called as Beer-Villiger oxidation reaction. As you know that in Beer-Villiger oxidation reaction, there is oxygen insertion and peracid is used as a reagent. Let's see, this is the ketone molecule which is the starting material of the Beer-Villiger rearrangement, and when it is treated with peracid, oxidation is taking place and there is insertion of oxygen and there is formation of ester as a product. In Beer-Villiger rearrangement reaction, peracid like perbenzoic acid, peracetic acid, metachloroperbenzoic acid, this type of reagents are used as a catalyst. In Beer-Villiger rearrangement, migratory aptitude is very important. When there are two groups present, out of that two group, which group is going to migrate, that is given by migratory aptitude, and this migratory aptitude in Beer-Villiger rearrangement is tertiary greater than secondary greater than benzyl greater than phenyl greater than primary alkyl. Hence, if tertiary alkyl group is present, then it migrate preferentially. Then another rearrangement we have already studied, that is Favoroski Rearrangement. Favoroski Rearrangement, in Favoroski Rearrangement, alpha haloketone is used as a starting compound, and this alpha haloketone on treatment with base, there is production of acid or ester. If NaOH or KOH, this type of base are used, then we get carboxylic acid as a product, and if sodium ethoxide, sodium methoxide, this type of base are used, then we get ester as a product. In Favoroski rearrangement, alpha haloketone is the starting compound. You have to remember this alpha haloketone, which is the starting material of the Favoroski rearrangement. And another thing you have to remember that Favoroski rearrangement consists of 3-member cyclic ketone as an intermediate. Then we have also seen pinnacle rearrangement. It is the rearrangement of 1,2-diol or vicinal diol in presence of acidic medium. Pinnacle is 1,2-diol or vicinal diol. When it is treated with acid catalyst, there is formation of pinnacle, and that's why it is called pinnacle rearrangement. in this rearrangement also migratory aptitude is very important, and when aryl group is present, it migrates preferentially, then tertiary alkyl, then secondary alkyl, then primary alkyl. Another thing, the loss of OH group is taking place, which produce more stable carbocation. Lawson rearrangement is the another rearrangement. In Lawson rearrangement, there is a derivative of hydroxamic acid as a starting compound, and when this derivative is heated or when it is treated with base, there is formation of isocyanate as a product, and when this isocyanate is treated with amine, there is formation of amide, or when it is hydrolyzed by using water, there is formation of amine. This is Lawson rearrangement. Means in Lawson rearrangement, you have to remember that isocyanate intermediate is formed and the starting compound is the derivative of the hydroxamic acid. Another rearrangement, that is Smith rearrangement. In Smith rearrangement, reaction of carboxylic acid or aldehyde or ketone with hydroxylic acid, that is HN3, in presence of strong acid, it produces isocyanate or nitrilium ion as an intermediate, and after proper treatment of this isocyanate, you get primary amine or amide as a product, and this is called Smith rearrangement. In this reaction, it is shown that carboxylic acid, when treated with HN3, that is hydroxylic acid, in presence of sulfuric acid, isocyanate is formed, and when hydrolysis of that isocyanate is taking place, there is formation of amine as a product. If ketone is the starting material, in that case you will get amide as the product, and if aldehyde is starting compound, then formamide derivative is obtained as a product. Now courteous rearrangement. In courteous rearrangement, acyl azide is used as a starting compound. Heat treatment with acyl azide, there is formation of isocyanate, there is elimination of nitrogen gas from the starting compound, and when this isocyanate is treated with various type of nucleophilic reagent, there is formation of various product. This is courteous rearrangement. In this rearrangement, you have to remember the starting material of this rearrangement, that is acyl azide, and another thing you should remember that isocyanate is the intermediate which is involved in courteous rearrangement. Now glycine rearrangement is the rearrangement of allyl vinyl ether. This allyl vinyl ether on heat treatment undergo 3,3 sigma-trophic rearrangement, and there is formation of gamma delta unsaturated carbonyl compound. The reaction is having concerted mechanism, that all bond breaking and bond formation taking place simultaneously. Co-rearrangement is the another sigma-trophic rearrangement. It is also 3,3 sigma-trophic rearrangement. 1,5-dione is converted to its isomeric 1,5-diene is converted to its isomeric 1,5-diene, and this is called co-rearrangement. Only carbon atoms are involved in co-rearrangement. If oxygen is present, if hydroxyl group is present at third position, then it is called oxy-co-rearrangement. But in co-rearrangement, all atoms are carbon. This is the difference between co and oxy-co-rearrangement. In oxy-co-rearrangement, OH group is present at third position, and in co-rearrangement, all atoms are the carbon atoms. Now we are going to start multiple choice question based on rearrangement reaction. Let's see the first multiple choice question. Rearrangement reaction includes dash dash. Your options are change in carbon skeleton, change in functional group, movement of substituents, all of the above. We know that rearrangement reaction involves the migration of one group from one place to another. That's why movement of substituent is one of the option. We know that in rearrangement reaction there is change in functional group. Change in functional group may be possible. That's why this is also correct option. And there is change in carbon skeleton. That is also correct. Means all of the above. This is the correct answer. Now second question. the alpha halocyclic ketone in presence of base NaOH converted into cyclocarboxylic acid by dash dash rearrangement. For solving such type of question, you should remember the starting material which is required for various rearrangement. And we know that alpha haloketone is starting material of the Favoroski rearrangement. That's why the Favoroski rearrangement is the correct option, and this is the reaction. In this case, cyclic ketone is shown and reagent NaOH is added, and there is formation of carboxylic acid as a product, and this is nothing but Favoroski rearrangement. Hence the correct answer of this question is Favoroski rearrangement. Third question, Wagner-Merwin rearrangement involve dash dash non-classical carbocation, classical carbocation, oxonium ion intermediate, nitrine intermediate. During study of this Wagner-Merwin rearrangement, we have seen that this rearrangement consists of non-classical carbocation. In this figure, it is shown classical as well as non-classical carbocation. Non-classical carbocation means the carbocation with 3-center 2-electron bond. That is 3 atoms sharing 2 electrons. That is the non-classical carbocation. And this non-classical carbocation is the part of Wagner-Merwin rearrangement. That's why option A is the correct option of this question. Now next question, in dash dash rearrangement, ketone is converted to ester. Option 1 or option A, that is Beckman rearrangement. Option B is Hofmann rearrangement. Option C is Baeyer-Villiger rearrangement. Option D, all of the above. We have seen that in Baeyer-Villiger rearrangement there is oxygen insertion and ketone is the starting compound. When oxygen is added to ketone, there is formation of ester. That's why in this question, Baeyer-Villiger rearrangement is the correct option, because we know that in Beckman reaction there is oxime derivative. In Hofmann reaction, amide is the starting compound, and in Baeyer-Villiger rearrangement, ketone is the starting compound. That's why Baeyer-Villiger rearrangement is the correct option of this question. Question number 5. In dash dash, exchange of alkylidine fragment take place. First option, 1,2 rearrangement. Second is pericyclic rearrangement. Third is olefin metathesis, and fourth or D, that is Hofmann rearrangement. In 1,2 rearrangement, migration of the group from 1 and 2 position they are taking place. In pericyclic rearrangement, there is movement of pi electron as well as sigma electron is taking place. Hofmann rearrangement, we know that amide is the starting compound. That's why only option is remaining, olefin metathesis. In olefin metathesis, exchange of alkylidine group taking place. In this example, let's see, 2 alkenes are shown. R1 and R2 are the part of first alkene. R3 and R4 are the substituent of the second alkene. And when olefin metathesis is taking place, the R3, which is the part of second molecule, joined to first molecule, and R2, which is the part of first molecule, that joined to second molecule. Hence, there is change of alkylidine fragments, and that's why it is called olefin metathesis. Question number 6. In which rearrangement 1,2-diol is converted into ketone? It's very simple. 1,2-diol, that is vicinal diol, is converted to ketone in pinnacle rearrangement. And this is the reaction. In this reaction, it is shown that 2 hydroxyl groups are present in starting compound, and it is called as 1,2-diol. When it is treated with acid, there is formation of the ketone as the product. Hence, the correct answer is pinnacle rearrangement. Question number 7. Which of the following rearrangement do not involve nitrine intermediate? Now let's see. In Hofmann rearrangement, starting compound containing nitrogen because it is amide. In Smith also, it is containing nitrogen. In courteous also, Acyl azide is the starting compound and it also containing nitrogen. That's why all three compound containing nitrogen, that's why nitrine intermediate may be formed in A, B, C. Only option remaining Favoroski rearrangement, and we know that in Favoroski rearrangement alpha haloketone is the starting compound, and that's why Favoroski rearrangement is the correct answer of this question. Question number 8. Nitrine is formed in which of the following rearrangement? Beckman rearrangement, Oxymes is the starting material, pinnacle rearrangement, ketone is the starting material, Favoroski rearrangement, alpha haloketone is the starting material. That's why courteous, that is the only option remaining here. And in courteous rearrangement, nitrine intermediate is formed. It is shown in this mechanism that there is formation of nitrine intermediate. Question number 9. Nylon 6 should be formed in which of the following rearrangement? 4 options. Option A is Beckman rearrangement, option B pinnacle rearrangement, option C Favoroski rearrangement, option D courteous rearrangement. This nylon 6 can be formed in Beckman rearrangement. Let's see how it is formed. This is the mechanism of Beckman rearrangement. In Beckman rearrangement, there is formation of E-caprolactam as a product, and when basic hydrolysis of this E-caprolactam is carried out, there is formation of nylon as a product. Question number 10. In dash rearrangement, acyl azide is converted to isocyanate intermediate. Means in which of the reaction acyl azide is the starting compound? In other words, options Beckman rearrangement, pinnacle rearrangement, Favoroski rearrangement, courteous rearrangement. And the correct answer, acyl azide is starting compound or starting material of courteous rearrangement. This is the courteous rearrangement. In courteous rearrangement, acyl azide is converted to isocyanate, and isocyanate undergo hydrolysis to produce that corresponding product. Question number 11. In Beckman rearrangement, which group migrates? We have already seen that in Beckman rearrangement, oxime is the starting material and oxime contain OH group. Hence, migration of group is very important. Option A is syn to OH, B anti to OH, both syn and anti, and D none of these. Correct answer is anti to OH. Means the group which is opposite to OH group, that is going to migrate. In this reaction, it is shown that CS3 group have anti with respect to that OH, and that's why that CS3 is going to migrate. Question number 12. Favoroski rearrangement is dash dash. Option A, conversion of alpha haloketone to acid. Option B, primary amide to amine. Option C, primary amide to secondary amine. Option D, conversion of alpha haloketone to phenol. Favoroski rearrangement, we know that alpha haloketone is the starting compound. That's why option B and C, they can be eliminated. Only option A and D is remaining. Now we have to choose between A and D. A is conversion of alpha haloketone to acid, and D is conversion of alpha haloketone to phenol. And we know that in Favoroski rearrangement, acid is formed, phenol is not going to form. That's why A is the correct option, conversion of alpha haloketone to acid. Question number 13. In Baeyer-Villiger rearrangement, migration of group mostly proceed with dash dash. A, retention of configuration. B, inversion of configuration. C, racemization is the product, means some molecule with retention of configuration and some molecule with inversion of configuration, that is called racemization. And D, all of the above. Correct answer of this question is retention of the configuration when there is optically active compound. In this case, R3-methyl 3-phenyl 2-pentanone is converted to R1-methyl 1-phenyl propyl acetate. Both starting compound as well as product have R configuration. That's why there is retention of the configuration, and option A is the correct answer. Question number 14. Oxymes are the starting material in which of the following? Pinnacle rearrangement, courteous rearrangement, Smith rearrangement, Beckman rearrangement. Pinnacle rearrangement consists of 1,2-diol or vicinal diol as a starting compound, courteous acyl azide. Beckman rearrangement contain hydroxyl amine, means ketone treated with hydroxyl amine, there is formation of oxime. Hence, option D is the correct option. Beckman rearrangement consists of oxime as a starting compound. The ability of group to migrate is known as dash dash. Migrating group, migratory aptitude, migratory terminus, migratory origin. Migratory aptitude is the correct answer because migratory aptitude is used to decide which group is going to migrate. Question number 16. In dash dash, cyclopropanone intermediate is formed. Beckman rearrangement, Favoroski rearrangement, pinnacle rearrangement, courteous rearrangement. And we know that in Favoroski rearrangement, this type of intermediate is formed. In this reaction, it is shown. If you see this reaction at third and see the third structure, in that case, cyclopropanone ring intermediate is shown, and hence in Favoroski rearrangement, cyclopropanone intermediate is formed. 17. In Favoroski rearrangement, if amine is used as a base, then product is ester, amine, amide, ether. If we use amine as a base, then there is formation of amide as a product, because let's see, this is alpha haloketone. When amine is used as a base, in this case secondary amine is used as a base, and there is formation of product which contain CON bond, and it is amide. This is amide. Question number 18. In dash dash rearrangement, orthoacyl derivative of hydroxamic acid on heating with base produce corresponding isocyanate. In Hofmann rearrangement, amide is the starting material. In Favoroski, alpha haloketone is starting material. In pinnacle rearrangement, 1,2-diol is the starting material. That's why only option remaining, that is Lawson rearrangement. In Lawson rearrangement, orthoacyl derivative of hydroxamic acid is converted to isocyanate, and that is the correct answer, that is Lawson rearrangement. In this reaction, it is also shown that hydroxamic acid is first converted to orthoacyl derivative, and after that, when it is heated or treated with base, there is formation of isocyanate. This isocyanate on hydrolysis with water produce amine, and if amine is used as a solvent or used as a nucleophile, then amide is the product. That's why correct answer is Lawson rearrangement. Question number 19. The migratory aptitude is greater for tertiary, primary, secondary, same for all the groups. In rearrangement reaction, migratory aptitude is very important when more than one groups are present or available for migration. In that case, migratory aptitude tell us which group is going to migrate, and migratory aptitude is always tertiary greater than primary, greater than secondary, greater than primary. Hence, if tertiary group is present, then it is going to migrate. That's why migratory aptitude of alkyl halide. It is shown like this, and the correct option is tertiary. Tertiary have the greater migratory aptitude. Question number 20. Glycine rearrangement is option A 3,3 sigma-trophic rearrangement, second option 1,3 sigma-trophic rearrangement, third option 3,1 sigma-trophic rearrangement, fourth option 1,1 sigma-trophic rearrangement. We have already discussed in glycine rearrangement there is 3,3 sigma-trophic rearrangement. There is simultaneous bond formation as well as bond breaking taking place. Mechanism is concerted mechanism, and 3,3 sigma-trophic is the correct answer. Question number 21. Which type of isomers are formed in rearrangement reaction? Option A structural isomer, option B geometrical isomer, option C conformational isomer, option D optical isomer. We have seen the definition of rearrangement reaction, and in rearrangement reaction we have seen that there is migration of one group from one place to another, or there is change in the functional group, or there is change in carbon skeleton. That's why structural isomers are formed during rearrangement reaction, and that is the correct answer, answer A, that is structural isomers. This answer is correct answer. Question number 22. What is the main difference between Hofmann and courteous rearrangement? Option A, intermediate form is different. B, products are different. C, reactants are different. None of these. We have to compare Hofmann and courteous rearrangement. In both of these rearrangement, isocyanate intermediate is formed. But in Hofmann rearrangement, amide is the starting material, and in courteous rearrangement, acyl azide is the starting material. That's why reactants are different is the correct option. Question number 23. In which medium Favoroski rearrangement occur? Option A neutral, option B acidic, option C basic, option D any of these. We know that in Favoroski rearrangement, alpha haloketones treated with base like sodium hydroxide or alkoxide, and it produces cyclopropanone intermediate. And finally, basic is the medium which is used in this Favoroski rearrangement, and the correct answer is basic medium. Question number 24. Which was the first molecular rearrangement identified as such by early chemist? Pineal rearrangement, Wolf rearrangement, Favoroski rearrangement, courteous rearrangement. The correct answer of this question is pineal rearrangement, and this rearrangement is first observed by the chemist. Question number 25. Which of the following is not carbon to nitrogen migration rearrangement? Option A Hofmann rearrangement, option B Beckman rearrangement, option C courteous rearrangement, option D Favoroski rearrangement. Now for solving such type of question, you should remember what is the starting material for all this type of rearrangement. If you find the starting material, then answer of such question is very easy, because in Hofmann rearrangement, amide is starting compound, it containing nitrogen, that's why carbon to nitrogen migration is possible. In Beckman rearrangement, oxime is the starting compound, it also containing nitrogen, that's why nitrogen to carbon migration is there. In courteous rearrangement, acyl azide, that is also containing nitrogen, that's why carbon to nitrogen migration is also there. Only option remaining, that is Favoroski rearrangement, and we know that alpha haloketone is the starting compound, and that alpha haloketone does not containing nitrogen. That's why there is no chance of carbon to nitrogen migration in Favoroski rearrangement. That's why Favoroski rearrangement is the correct answer. Question number 26. Which rearrangement reaction involved fragmentation of the molecular ion? McLafferty rearrangement, courteous rearrangement, Beckman rearrangement and Favoroski rearrangement. In our rearrangement chapter, only one rearrangement that is having the fragmentation pattern, that is the McLafferty rearrangement. McLafferty rearrangement is associated with mass spectroscopy. When we are taking mass spectrum of some compound, then McLafferty rearrangement is observed. It is shown here how that McLafferty rearrangement is taking place. Fragmentation of the starting compound is taking place, means starting compound is break down into several fragments, and that fragments again going to break down to other fragments. That is observed in McLafferty rearrangement reaction. That's why McLafferty rearrangement is the correct answer. Question number 27. McLafferty rearrangement reaction involve dash dash transition state. 6-member, 5-member carbocation cyclopropane. 6-member intermediate is there because the gamma hydrogen atom is involved in McLafferty rearrangement, and if you count that 1, 2, 3, 4, 5, 6, it is 6-member transition state. 28. Conversion of 3-hydroxy 1,5-diene to 5-hexanal take place in dash dash. I repeat again. Conversion of 3-hydroxy 1,5-diene to 5-hexanal taking place in dash dash. Option A is Beckman rearrangement, option B is McLafferty rearrangement, option C is courteous rearrangement, option D is Oxymes rearrangement. If you see the starting compound of all these rearrangement reaction, then you are able to find out the correct answer. We have already discussed that in Oxymes rearrangement, hydroxyl group is present at 3 position and it undergo sigma-trophic rearrangement and there is formation of the product. Hence, Oxymes rearrangement is the correct answer. In this reaction, it is shown that how that bond formation as well as bond breaking is taking place. Question number 29. The most powerful migratory aptitude is found in pinnacle rearrangement is dash dash. Option A is aryl, option B is tertiary, option C is secondary alkyl, option D is primary alkyl. If you see the pinnacle rearrangement, in that rearrangement, if aryl group is present, then it is going to migrate. That's why answer of this question is aryl group, that is option A. Now question number 30. Lawson rearrangement process through formation of dash dash intermediate. Option A isocyanate, option B phenoxide ion, option C carbene, option D carbamate ester. And the correct answer is isocyanate, because isocyanate is formed in Lawson rearrangement. Now 31. Cyclohexane oxime on treatment with sulfuric acid gives alpha caprolactam, beta caprolactam, gamma caprolactam or E caprolactam. In this case, last option is the correct option. Thank you.